Hello, my name is Sebastian, and I want to talk something about security. Yeah? Did you ever wonder how much money is spent on cybersecurity worldwide? So last year it was like $200 billion. I think it's pretty big amount of money. For comparison, we see that GDP of Poland is over $600 billion. So it means like one third of Poles, one, two, three, you, and one, two, three, you, working in cybersecurity. So I think it's a lot. So in comparison with, for example, military budget worldwide, it's also a big amount of money. Military, tanks, nukes, soldiers, aircraft carriers, and a lot of very serious equipment. So you may wonder what we achieve with that. Yeah? A lot of money spent on cybersecurity and what we get. So I want to talk about some security incidents from the last year. Last year was very interesting for security people and IT people in general, especially some Fridays. Yeah, Friday is a very good day for cybersecurity incident and the weekend following and so on. Yeah. So I remember one day in December last year. It was Friday. Yeah. So I took my kids to preschool as usual in the morning, and I pick up my phone when I check the Twitter. Twitter is very big and good source for security news because you receive instantly every news from security people about new vulnerability, especially like if you watch tags like bug bounty tips or CBE new and so on. So I noticed someone posted up payload from log4j library. When I saw it, I couldn't believe it because it was so simple that I couldn't believe that it even worked. Everyone, I think here, especially software developers, even if don't use log4j library, knew what it is. It's very major library, widely used, with very long history, and the payload was so simple. So when I got back to home and ran some scans, it looked like everything on the internet responded to the payload. AWS, our applications, I got some wrote on some production server. You didn't hear that. So every service in the internet responded to this payload. So today I want to talk a little about this vulnerability and other vulnerabilities from the last year, because even if you patch them, you may want to know what was the reason, what was the cause of the vulnerability, and maybe draw some conclusions for us what to do next. Okay, so log4j library is widely used and so on, major, as I mentioned, and so on. And the vulnerability there was called log4shell because the impact was remote code execution. We like remote code executions because we can get a shell on the remote server and execute any command. So the server is totally compromised. To understand this vulnerability, let's introduce something about JNDI. JNDI is a legitimate functionality of Java platform used to communication, usually between some trusted parties, like your application talks to database using JNDI protocol. However, in 2016, there was a presentation on Black Hat by two pen testers who demonstrated a way to execute any code on Java application using JNDI protocol. So attacker is an attacker. The red part is attacker server, which serves some JNDI poisoned objects. And attacker instructs the application to connect with his server which delivers the payload. Application retrieves the payload and executes the code. It is possible because under the hood, the JNDI object can contain reference to, actually two options are possible. One is that the object returned by the server contains Java serialized data with some object. And second one is that it contains a naming reference to a Java code base, some factory, and a class which should be retrieved from this Java code base. So in this scenario, application connects to a remote server and retrieves the class from this Java code base and executes it. So pretty big impact. However, we need an entry point because the application needs to connect with attacker server. So in log4j library, there is a mechanism of lookups. Lookups are meant to be used in configuration to, for example, you can, if you want to log something, you can put in your logs name of the host name, thread name, some environment variable, and so on. Yeah? And one of the lookups here is a JNDI lookup, which allows to connect with JNDI. We can use some JNDI reference and connect to a JNDI service. And this functionality was appreciated because it was developed like in 2013, and it was appreciated much later by a project leader. And this is the reality of open source software. All you get is an appreciation. And when we read about the lookups in log4j documentation, and there is one important sentence that these lookups are meant to be used in configuration. But every QA, I mean, junior QA and pen testers should know, because seniors already knew that every word of a software developer, written or spoken, is a lie. So this is also the case here. These lookups can be used not only in the configuration, because when we find the method in log4j core, which is responsible for resolving these lookups, it's named resolve variable, and when we put a breakpoint here and prepare a very simple proof of concept, which is using log4j library to log some error. We are using error here because error is always logged. Yeah? So we are sure that this message here will be processed by library. And we use the lookup with proper syntax in this. We can see on the stack trace that this resolve variable method is not used only by when configuration is processed. It is used also with the user input. So anything which goes through this logging. So it's not good. It seems that we have an entry point which allows an attacker to instruct the library to use the JNDI lookup. And if you remember the first picture, now we have this connection between application server and attacker controlled server. So we can modify our proof of concept because even the possibility of making an arbitrary request is quite dangerous. Remote code execution is maybe not always possible because you can harden your Java, you can update the Java platform and so on. But even if you are able to arbitrary request, you can retrieve, for example, environment variable. In this case, AWS credential from the environment, and also achieve, in the end, the remote code execution. Yes, because we have full credentials to the environment. A lot of lookups is possible for Log4j library. Also, these lookups can be nested, so the payload can be obfuscated, so it's not easy to be blocked by some kind of bug. Okay, so let's go, because when we patched the Log4j library, then in the April, another vulnerability alert occurred. So Spring Framework is a base for many of our applications. I think that many of our applications are using Spring Framework, Spring Boot with the same mechanism. And Spring Framework is also a library with an old history. Yes. So very similar, or let's say the same vulnerability was found in 2010 and allowed an attacker to achieve remote code execution. So the idea was that if you have an application and this application is using some entity, like person, owner in this case, when you send this entity, you are able to set owners, first name, last name, and so on. Yeah, this is something which is expected. In the original vulnerability, the problem was that because it's Java, and in Java, every object derives from the class object, the class object has a field called class. So original vulnerability allowed you to access the class, and on the class you could change the class loader, for example, Tomcat class loader, web apps something class loader, and on this class loader modify the list of the URLs to point to the remote jar file on attacker controlled server. If you did this in proper moment, application retrieved implementation of web tags from remote server. So remote code execution was the impact for this. And this vulnerability was fixed, yeah, because it was serious, so it was fixed in Spring Framework. And two important, I think, conditions are here, yes? So we check the class of the bin, that is a class, so the type is verified, and the field is verified. So what we want to set on this bin, class loader by name. And what happened? After some years, in Java 9 and later, I think that it's a proper version, Java introduced something, some say abstraction above packages, which was called modules. So on each class, a new method was added, accessor for which returns the module, and module also has a class loader. So what was now possible? Because when you read the original vulnerability, a lot of people will say that this vulnerability is only applicable to Tomcat. It's not true. Yes, you have Spring and you can access something, some fields on objects below, exposed by the module. And what you can achieve depends on the platform. And for our applications, Jetty is embedded with the Spring Boot, so it's a very popular, let's say, combination. So we can access now the module, not only class. Module is not blacklisted, class loader on this, and context. Context is a Jetty context. And on this context, there is a lot of fields, but not all of them are, let's say, interesting. So one is available, which is Boolean, true, false. So we can achieve denial of service. Some impact, but maybe not so, let's say, impressive. And second interesting is resource base, which says to Jetty from where retrieve the resources, like JSP files, classes, and so on. So it's much bigger impact, especially that we are running on Java, and Java is very kind to developers that it allows to access files, but also remote files. So we can set resource base to something remote, like HTTP something attacker server directory. So now what we need to do is to set up our server with webinf directory, some file JSP, and tags plugin. Tags plugin is required because Jetty first retrieves this tags plugin XML file, so you can place anywhere any file with this name in the server, and then it retrieves the JSP file. And we need the HT access on this. So for each request, our CND JSP file is returned in plain text. Note, this is, let's say, the server is pure Apache, no JSP, no Tomcat there. So we return this text. And on application server with vulnerable application, command is executed. So replace the calculator with something else, like some coin miner, for example. And we have an RC. So yeah, in this case, we had a change in the environment. Yes, original fix, if you remember, assumed something. The type of the bean is class, and verified the fields also by name, not by type. And this assumption was wrong. After many years, the platform was changed, and this vulnerability, original fix, was bypassed. So we had a bypass because some assumptions for the patch were wrong after some time. Okay. And the last one, let's stop talking about some amateurish libraries like Log4j or Spring. Let's focus on Java platform. Java is a secure language, so for sure there are no bugs here. Yeah? But in some version of Java, like JDK 15, I believe, someone decided to rewrite implementation of code responsible for handling the electric signatures from C++. You know, C++ is insecure language. Let's rewrite it to Java. Yeah? Java is secure, so it will be more secure. And in this rewrite, a simple, let's say, trivial bug was introduced. If you remember the ECDSA signature algorithm, then you are good, and maybe you should go sometimes outside, yeah, because there is plenty of much funnier things to do. But if you don't, then only thing you need to understand is that within this algorithm, there is one place where multiplication is used. And in multiplication, if you multiply something with 0, then you receive 0 as a result. This is a definition, mathematical definition of multiplication operation. There should be a neutral element and 0 element. And in original implementation, this C++1, a check was done for two important parameters that they are not equal to 0. So we have this check, yes, we need something bigger than 0. Otherwise, we report an error. But in Java implementation, the check was missing, simply missing. So it was possible to send 0 in the signature. So with JWT token, if you have a token which specifies ES algorithm, you can change the algorithm because its header, the user submits the header for the token. You can change the algorithm in the header. And instead of valid signature, which is hard to compute, this is the idea, yeah, we can't forge it, we can send this string, which means two variables equal to 0 in their format. You can take the OpenSSL command to decode this, and you will see two integers equal to 0. So this token on vulnerable version, on the affected version of Java, will be always valid, regardless of content. So you have a bypass on this. So pretty big impact, because we use JWT tokens to authenticate users. So if there is an authentication bypass, then it is pretty big impact. And the reason for this, lack of, let's say, regression testing, lack of proper review by the cryptographer during the rewrite, because we are rewriting existing functionality. What could go wrong? Yeah? And we have this impact, which was easily fixed from our perspective. Just update the Java version. No one is using old versions of Java. Yeah? So no big impact for us. I think that everyone updates the Docker base images regularly. Yes, of course. Yeah. So conclusions. Let's draw some conclusions for us. I think the motto from the corridor is the best here. Expect the unexpected. So in Log4j, it was an old major library used by everyone. No one expected insecure functionality in library used for logging, so putting something in text files for later review. But the vulnerability was there. So when you want a pen test, maybe it's not the best idea to limit the scope or say that some parts of the application don't need to be verified, don't need to be audited. Because you can expect vulnerability in every component you use. So the second one, if we can expect vulnerability from every part of the application, is to mitigate the impact. You'll be prepared that for sure incidents will happen. So with this Log4j, I remember that it took some time to catalog all impacted applications, to find if you are using this library or not, to patch it, and so on. So we need something first to, like, bill of materials directory, which collects components we are using, in which version. So in the case of next vulnerability, which will happen for sure, we are able to find who is impacted. Yeah. And the third one, last, is that we need to review our codes, because most of the code in your application is from third-party components. Yeah. The code you write is rather small in comparison to external libraries. So review your libraries. Maybe some need some kind of update. Also, if you are using third-party components, which are, let's say, outside of control by security from some external repositories, and no one knows about that, then it is not possible for us as a security team to assess, to find what is used, and also to find if, in case of next vulnerability, it's not possible to find who is impacted. So please don't do that. And that's all, I think, from my side. Thank you.